Our next section, section 7.2 in chapter 7, has to do with modeling linear systems. Now remember, a system of equations really just means it's going to be two equations at the same time. So it means two or more equations. Okay? So what this really has to do with is we're going to be figuring out from word problems what are our two equations have to be. So with word problems, we need to derive our own equations. It's not like it's just, hey, solve this. So remember, for a systems of equations, you're going to be dealing with two equations, right? Because that's what a system is. But if we're going to be graphing them, that means an x and y graph, it means we're going to be using two variables, okay? Two variables. Usually we call them x and y, but you don't have to. You can call them anything you want. You can call them Frank and Mary if you want. So the first step is we're going to have to define what variables we're using. So we have to define variables. Variables. So in other words, what does X stand for? Is it the number of X-rays or is it the number of apples or what? And derive two equations. So derive, so we have to figure out two equations, two different equations. One's not enough because remember, if it's a system, it's got to be at least two or more. Okay, so let's give these a shot. So here we're just giving the system. We're not actually solving it, just give the system of equations. Okay, so it says, for example, there's 59 vehicles in the parking lot. The number of cars, or sorry, the number of trucks is 4 less than double the number of cars. So what are the two things we're dealing with here? Well, we're talking about trucks and we're talking about cars. So instead of calling it X and Y, I'm going to call it T and C. So I'm going to say T is the number of trucks. And I'm going to say C is the number of cars. So step one, that's what I want to do. The first thing I do is I define what variables are. So what do they mean? What does T stand for? Obviously T is going to stand for trucks, okay? So I need to figure out two different equations. Now here's a very, very common one. It says there's 59 vehicles in the parking lot, comma. So that's a piece of information. That's a total, right? They told you there's a total of 59 vehicles. So I know the number of cars and the number of trucks. I know that T plus C should equal 59. Okay, that's my first one. There's 59 vehicles in the parking lot. That's one equation. So, and I need another equation now. And that's where the other one comes in. It says the number of trucks is 4 less than double the number of cars. So the number of trucks, remember we call that T, is equals 4 less than, so that means something take away 4, double the number of cars. Double the number of cars. There it is. See? Trucks is 4 less than means it comes at the end. Double the number of cars is going to be 2 times C. And here we go. So I can just say T is equal to 2C minus 4. Now, we haven't rearranged this into like y equals mx plus b form, right? Because we're not actually graphing this. We're not, yeah, we're just solving, or we're just giving the system. So there's one equation, there's the other one, and there's my variables. I'm done. That's all I have to do. I'm not actually solving this one. It just said give the system. Okay, let's try another one. How about this? A piggy bank. It's a loony and a toonie piggy bank. It has 100 coins in it, and it's worth 139 bucks. Okay. Um, well, what are the two things we're dealing with? Loonies and toonies. So I'm going to say L is equal to the number of loonies. And I'm going to say T. Now, you know what? If you're going to be using a T, a script T like this is a better idea, because that T kind of looks like a plus, right? I have a terrible handwriting for this thing. So T is going to be the number of toonies. Is that how you spell toonies? Or is it like with an O? Maybe it's like this. Toonies. But toonies with it, that's townies. Okay, that's obviously wrong. Toonies, I don't know. I'm going to say it's loonies and toonies. So that's L and T. Okay. So you remember how with the other one we had this plus this is equal to, that's the exact same thing. It has 100 coins. That means it's a total. Remember? A total just means it's going to be L plus T. So usually one of the easier equations is usually going to be something like L plus T is equal to 100. Done. That's one equation. Now the other one is how much they're worth. Now, careful. Loonies are worth $1, right? Toonies are worth $2. Okay, so if we're talking about what they're worth, 1 times L, which is just L, plus 2 times toonies. Okay, so this is now how much they're worth. Worth is different. This is the total number of them, but this is what they're worth. So I need two equations. Yeah, 1L plus 2 times the number of toonies, because they're $2 a piece, should equal 139. That's it. There's my equation. I really just could have written it as L plus 2T is equal to 139. But that's it. There's my two equations. Remember, these don't say solve. It just says give a solution, or sorry, give a system. Okay. How about this next one? This one says adult lift tickets cost $95. Youth ones are $65, and it says there's 400 people on the ski hill. That's a total. Always think about that. And they took in $30,800 in lift tickets. Okay, so that's how much they made. Well, that's really how much it's worth in dollars, right? Or how much money they made, if not after profit and all that, but just from the lift tickets. Okay, so what are we dealing with here? Adult lift tickets, youth tickets. I'm going to say this one's A, this one's Y. You can call them whatever you want. Call them X and Y, but it kind of makes sense to use the right letters. Okay, so this is the number of adults, or adult lift tickets, and Y is going to be the number of youth lift tickets. Okay, do we have a total? There's 400 people on the ski hill. Yes, that's almost always going to be one of them. So A plus Y is equal to 400. That's the easiest one. Usually if they give you the total, there it is. 400 people on the ski hill, okay, comma, and they took in 30,000. Okay, so much like the loonies and the toonies, how much are the adults worth? The adults are, they're $95 a piece. Okay, so my other equation is going to be 95 times A, and the youth ones are going to be 65. Now, should I add or subtract? They took in 30,000 in total, so it's going to be something plus something. You're right. So it is going to be $65 times the youth. 65Y. If I add those money from that and the money from that, that should be 30,800. Now you can probably see why we're just setting up the equations. I'm not actually graphing this thing. This would be huge. 30,000, that's a pretty big graph, right? And yeah, look, even if I wanted to rearrange this, y is equal to mx plus b. Think about it, right? Move that over. The slope is -1 and the y-intercept is 400. Okay, I'm not graphing that thing by hand. No way, not right now. That's a big, big job. Okay, who's next? Oh yeah, this one. The Spruce Kings had a fantastic year. Okay, it's not realistic, but let's say they did. They had 0 losses, okay? No losses. So they get 2 points for a win, 1 point for a tie. So we're talking about wins and ties. W and T. W is going to be the number of wins. Okay, and this is the number of ties. Okay, it says they got 2 points. Oh, hang on. No losses, 2 points for a win, 1 for a point. So that's the number of points, and there was 85 points. So I should just go wins plus ties is equal to 85. No. Careful. This is the points. This is their total. Oh yeah, if I go W plus T, that's the total number of games. What about losses? There were no losses. Okay, so this shouldn't be equal to 85. This once again is the total. They played 48 games in total. W plus T is 48. They got 85 points. Now, when we're talking about points, wins are worth 2. So 2 points for every win, plus 1 point for every T. I don't need to say 1 times T. I can just say T. That's equal to 85. There we go. There's my two equations. Once again, I'm not graphing these because these would be huge, huge numbers, right? But it just says set them up. So when we do start doing these into word problems, we are going to have a few steps, okay? So usually the first thing I do in every one of these is over here. I say, what is W, what is T? So step 1, you have to define your variables. Define variables, because I don't know what they mean. Is W stand for the number of watermelons? I don't know. Define your variables. Yeah, and you don't have to use X and Y. So you can use any letter, right? So it doesn't have to be just X and Y. But I mean, if you like X and Y, go ahead, fill your boots. I always like using x, right? X and y is kind of nice because you know how to graph x and y. Oh, okay. So we're going to define our variables. Yeah, in these cases, we didn't use x and y. We used w and t. Okay. So then, once I actually get my variables, I need my two equations. So I need to derive, so in other words, figure out two different equations. Okay. Now the next step would normally be solve them. Well, how do we solve them? We solve by graphing. Now, don't worry. They're not all going to be huge numbers. The ones we're going to start off with are going to be okay. Yeah, it's not going to be this 30,800 because there's a different way of doing these, not by graphing. You can do it algebraically. We'll get into that later on, not right now. So the ones we are going to graph, they'll turn out to be okay. Or they'll say, by the way, use a big graph this size or whatever. So solve by graphing, and you actually get an x and y point. So you get your x and y point. In other words, the solution is the intersection point, right? Okay. Now, the last part is kind of a well, duh. Well, the last part is now answer the question. What? Answer the question. So careful. Sometimes if you get an answer and the answer might say what is the x value and what is the y value, then you'd get both. However, if the question is just asking for the x value, you don't give it as an x and y point. You just say the x value is this. So here's what you have to do. You also have to consider if the answer is appropriate, because sometimes it's not. In other words, sometimes it's a garbage answer. It doesn't make sense. So consider if the answer is appropriate. What do you mean? Well, let's say you're solving a word problem that had to do with two people's ages, and the answers you got were -500 and -8,000. Can't have negatives. So you would throw those away and say there isn't an answer for that one. Or if you did get an answer of 7,000, do you know anyone that's 7,000 years old? No. That might be an inappropriate answer, okay? So let's actually try one of these. Okay. How about this? Let's say you want to be renting a snowboard, okay? There's two different options you can do. You can do it for $30 a day, and it's $8 an hour, or you can just get it for $14 an hour, okay? So $30 per day, and so it means going to be something plus something. I'm going to add these two together. This is just $14 per hour, okay? So there's going to be two different ways of doing this. So the cost of renting a snowboard comes in two options. Which option is better? Well, I don't know. What's my first step? Define your variables. What are we talking about? We're talking about money. So we're talking about the cost. So I'm going to say C is going to be the cost, right? Well, the cost kind of depends upon the number of hours, right? If you do it for an entire day or just an hour or 2 hours, 3 hours. So I'm going to call that T. Let's say T is going to be time. And yeah, that's going to be in hours. Per hour, per hour. Okay, so I've done my two variables. Great. I need to have two different equations. Okay, so this is the easiest one. The cost equals $14 per hour. So it's just 14 times the number of hours. It's just 14 times T. That's it. Okay, so then that's part B. Now what about part A? What's the cost going to be here? The cost is going to equal, it's $30 per day and $8 an hour. So it's going to be $8 times the number of hours, right? 8 times number of hours. That seems to be cheaper, plus $30. Now this $30 is just a one-time charge, right? So recognize this, y equals mx plus b. This is the same idea. So b is the y-intercept where I'm starting. You're starting at $30 when you go with option A. It's going to cost you $30 anyways. And then every hour it's going to go up by $8. So 8 is really the slope. Okay, so there's one equation and there's the other one. So I don't know what's x and y, but you know what? Look, y should be c. It fits this pattern, right? Y equals mx plus b. There it is. Y equals mx plus b. So let's say y is the cost, and that means the t, time. Well, that's right, time. Anytime you see time, time is 99.99% of this time on the x-axis. The reason for that is the x-axis, the one on the bottom, it's actually called the independent axis, and this is the dependent. So in other words, the y value depends upon the x. Everything depends upon time. Time does not depend upon anything, right? Okay, so I need to figure out, okay, so how am I going to do this? Let's see. This is going to be time. Okay. Well, how big should my scale go? Should I go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16? Should I go up to 16? Nobody rents a snowboard for 16 hours. You know what? Maybe I'll count by 2, because like even 8 hours is a pretty big day on a ski hill. Okay, so here's the idea though. If this is the origin, it's got to start at 0. Now I can't do this. I can't go 1, 2, 3, 4, because you see they're not evenly spaced. No. If I'm going to do 0 to 1 is 1, that means every distance of 1, 2, 3, 4, 5, 6. So you can't change the spacing. Yeah, if you change the spacing, it wrecks all graphs. That doesn't work. So I'm not going to do that. I'm not going to go 1, 2, 3, 4, 5, because right, that goes all the way up to 16. It's way too big. Let's double space it here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's a decent size, right? That's a decent size graph. Okay, let's not worry about that right now. Now, what about the other one over here? This is the cost. Now, I don't know what the cost is, but let's say I actually did it for 8 hours. What's 8 times 14? Well, it's really 80 and 32. It's going to be like $112. So I need to go, I'm not counting by ones, right? 1, 2, 3, 4, 5, 6. No, that's not a good idea. I need to go up to at least $100, probably more. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There's $100. Maybe I could do the same thing here. You know what? I'll count these by 5s. So, okay, so I need to see if I can get an axis here. Oh, it's a terrible line. Oh, that's even worse. We'll get rid of some of this. Maybe I can do it from the top down. I really need a ruler. Okay, so you know what? I'm going to count by, there's 10, 20, 30, 40, 50. Hopefully this will work. 30, 40, there's $50. Okay, and then I'm just counting by 2. 60, 70, 80, 90. There's 100. Okay, so I don't know if I'm going to be going for a full 8 hours, but let's just see. 60, 70, 80, 90. There's 100. Now, I'm not going to call these X and Y because they're not X and Y anymore, right? Oh, yeah, that's right. It's time and cost. So I should put the cost over here. Cost, and this is in dollars, and time, this is in hours. Okay, so let's get rid of this. It's not Y. So really, if I want anything, this is the C-axis, not the Y-axis. And this isn't the X-axis, this is the T-axis, right? Okay, this is T and C. Okay, so let's graph this one. Y is equal to mx plus b. So this one starts at 30 and has a slope of 8. I know it starts at 30. And it has a slope of 8. 1, 2, 3, 4, 5, 6, 7, 8, and over 1. No, that's not right. That's 8 blocks in 1, but we didn't go up 8. That went up 10, 20, 30, 40, and it went over a half. Okay, so, oh yeah, because this isn't 1. So even if I go up 8, there's 5. 8 is going to be around here, and then over 1. If I go up another 8, 16 and 30 is like 46, and then okay, it's not very accurate, is it? No, it's not very accurate. It's not a smart way of graphing this. I do know, I'm not going to graph that, and I'm not going to graph that. I do know that that's a dead-on point. Great. Let's figure out another dead-on point and use a ruler. Once you know another point, you can just draw it, okay? So let's say, I don't know, if I plug in 1 hour, 2 hours, 3 hours, right? This is kind of like function notation. What if I did 5 hours? Why 5? Because what? 8 times 5 is 40. That's dead on. Yeah, so at 5 hours, it's going to be 40 plus 30, $70. Okay, that's a good point to use. I know it's dead on. No, I just did that one in my head. I chose 5 because I know 5 times 8 is 40. It's a nice base 10 number, right? So at 5 hours, let's do this. At 5 hours, it should be exactly $70. There we go. You know what? I've got 2 points. Once I've got 2 points, I can actually draw a pretty straight line. I don't know if I can actually draw this well here. I'm trying to actually use a ruler. No, that's not good. No, that's not good. Was that a better one? Oh, almost. No. If I actually had a ruler, so close. That's the one I want. And then that line just keeps going. Okay. Man, I've made a mess out of this stuff. Let's see if I can get rid of some of these. Doop. Get rid of that. Oh yeah, that's not great. Okay. Okay, so if we get rid of those, okay, fire enough. Let's say pretty close. Close. You are probably doing a way better job than I am. Okay, so that should be dead on. So that's the first line, right? Now I'm going to do this one in a different color. Let's do a different color. Let's do this one in red. Yeah, just so it'll really stand out. $14 per hour. Now, this is like saying y equals mx plus b. Where does it start? It starts at 0. Oh yeah, it starts at 0 and it has a slope of 14. So this graph is going to start here and it goes up 14. Now don't count up 14 and over 1 because that's not up 14, right? Oh, that's right. So up 14 is 10, 15, 14 and over 1 is around there. It's close. And then the next one's going to be 28 and then over 2. It's not, I can kind of see it. But you know what? I'd be better off if I chose a dead on point, right? Now we know it starts at 0. That's a dead on point. This one we chose to use 5 hours, right? I did, because now what if I use the same 5 hours here? What's 5 times 14? Oh, hang on, let's use the same one. 5 times 14, right? As soon as you need 2 points, you got a line. At 5 hours, it's 7. Oh, what a nice coincidence. So this one is going to be a line, and it's going to go underneath, right? I can see. Oh, I missed it. Can I get a better line? Oh, that one's pretty close. And then it's going to go above because these are straight lines. If you have a ruler, and you probably do, your graph is going to be better than mine, right? But hang on, these two actually meet dead on at 70. Okay, so what does that mean? So 70 is the intersection point, and I want it to be this. Okay, so the intersection point is 5, 70. So in other words, at 5 hours, it's $70. So really, if you think about it, up to 5 hours, this one's always cheaper because it's below, right? Yeah, if you only went for 1 hour, it would cost you $14. Whereas with the other plan, it would cost you 30 and a little bit more. So this is the cheaper one until 5 hours. After 5 hours, then, okay, so which is, yeah, so plan B is cheaper for the first 5 hours. Right? And that's what this says. Which option is better? Well, it kind of depends. At 5 hours, they're both exactly $70, right? But if you went for 6 or 7 hours, then the blue line is actually less money because this one becomes more. Yeah, let's say you went for 6 hours. This one's going to be around what, 75, 76 bucks, whereas the other one is 85. So 5 hours, no difference, right? They're exactly the same. But beyond 5 hours, so plan A is cheaper after 5 hours. So yeah, it depends. If you're just going out for a few hours, the red one is the cheaper one. If you're going out for an entire day, it's going to be more than 5 hours, then you want to go with plan A. Okay, so these questions here on page 391, most of them have to do with setting up. So you're not actually solving the graph. Like this was a pretty big graph and I did a terrible job of drawing it, but if you have a ruler, you can be a lot more accurate. And remember, you don't have to graph every single point. As soon as you know 2 points and you have a ruler, you can draw a pretty accurate line. Alrighty, so good luck with these.